In this video, I introduce training large language models to learn summaries from human feedback. When a pre-trained large language model is applied to solve a specific task, it's usually fine-tuned using supervised learning to maximize the log probability of a set of human demonstrations. However, the expectation is how a large language model can generate outputs as good as human demonstrations. Therefore, there exists a discrepancy between maximizing the log probability and alignment with human judgments. One possible solution is to use human feedback to fine-tune large language models so that the model generations have a human preference. This is a learning diagram from human feedback. First, collect human feedback, then train a real-world model, or finally, train policy with PPO. In the first step, collect samples from existing policies and send comparisons to humans. Then learn a real-world model from human comparisons. Finally, optimize the policy against the real-world model. The real-world model, initialized by the pre-trained large language model, consists of a supervised baseline and randomly initialized regression head that outputs a real-world, as shown here. The real-world model is then trained on the human preference comparison data to predict which summary Y is better as judged by a human for a given poster X. If the summary preferred by the human is YM, the cross-entropy loss is defined as here, where R theta is the reward of the output summary Y given a poster X. Theta is the parameters of the real-world model, and D is the dataset of human judgments. At the end of training, outputs of a real-world model are normalized such that the reference summaries from the dataset archive a mean score of 0, namely sum of R theta 0. The trained real-world model is used to train a policy that generates high-quality outputs as judged by a human. Human feedback policy model is initialized by the pre-trained large language model. The standard fine-tuning is first used to train the pre-trained large language model on the dataset D SFT that contains poster summary pairs X, Y, written by humans, and results in a policy pi SFT. The model is then trained to autoregressively generate the corresponding summary Y given a random poster X. The human feedback policy is trained in the following steps. First, initialize the policy pi theta RL to pi SFT. Then I loop until convergence. First, initialize the new empty dataset D, and then loop over the post in the training dataset. First, sample a random poster X from D RL. Then generate a summary Y from the policy pi phi RL. Then calculate the real-world R theta from the real-world model. Finally, add a triple to D. And then update phi by using proximal policy optimization method to maximize the real-world expectation as shown here, where X, Y from D is equivalent to X from D RL and Y from policy pi theta RL. The second term here is used to penalize the KL divergence between the learned RL policy pi phi with parameters phi and the original supervised model pi SFT containing human judgments. The training procedure is shown here. First, the human summary fine-tunes the pre-trained model with supervised learning. Then here, PPO is used to train policy pi phi RL to maximize reward R theta and penalize divergence from pi SFT. For more details, please check with this reference. Thank you. Bye.